In a laboratory in China, a new type of computer has just come to life, a biological chip that uses live primate neurons to think. What if a robot, when damaged, could bleed a special liquid and heal itself right in front of you, like a living creature? This is no longer fiction. Meanwhile, elsewhere, machines are learning to dance, with Google teaching industrial robotic arms to perform complex work choreography in a matter of hours, not weeks. The future isn't just knocking on the door, it's being assembled, programmed, and now cultivated in the lab. Hello, pioneers of the future. Welcome to the epicenter of the news that is shaping our next reality. What seemed impossible yesterday is a prototype today, and tomorrow it will be our daily life. And our job here is to decode these changes. Today, we have an absolutely unbelievable summary of advances that seem straight out of a science fiction movie, from computers with monkey brains to spy drones that fly like eagles. Get ready. Without further ado, let's decode the future. Let's start with what may be one of the most profound and perhaps disturbing leaps in the history of computing. For decades, humanity has followed a clear path. Silicon chips, smaller transistors, more processing power. But this road, known as Moore's Law, is reaching its physical and, above all, energy limits. Today's large AIs, such as the language models we use, consume astronomical amounts of electricity, requiring data centers the size of cities. The human brain, in contrast, is the most efficient machine we know, performing complex tasks with the energy of a dim light bulb. What if, instead of imitating the brain, we could use it? Chinese researchers have just announced exactly that. They have created what is being called a biocomputer. It is not a simulation. It is a hybrid architecture that successfully integrates living neurons, grown from primate brain cells, directly onto a silicon chip. This device combines the processing power of silicon with the innate efficiency and learning ability of biology. In initial tests, the results were shocking. This biocomputer demonstrated an ability to learn new tasks significantly faster than 100% digital AI architectures. More than that, it did so while consuming a tiny fraction of the energy. The simplifying analogy here is crucial. Think of a traditional AI chip as a musician who needs to learn an entire symphony, note, by reading a gigantic score from scratch. It is a slow, meticulous process that requires immense effort. The biocomputer, on the other hand, is like a master musician who already understands harmony, rhythm, and melody. You don't need to teach the notes, you just need to show the feel of the music. Living neurons already have the plastic ability to form connections, adapt, and learn intuitively, something that software engineers spend years trying to replicate in code. The future implications of this are breathtaking. We are talking about a potential new paradigm for artificial intelligence, an AI that is not just programmed but cultivated, a machine that learns organically. This could solve the biggest bottleneck in AI, energy consumption. But it also opens an ethical Pandora's box. Where does computing end and consciousness begin? If a computer uses living brain cells to process information, what are the limits? For the first time, we are looking at a horizon where the difference between living and artificial may cease to have any meaning, from the factories of today to those of tomorrow. For a long time, industrial robots have been the backbone of manufacturing. Giant arms that weld, paint, and assemble cars with absolute precision. But they have a secret. Most of them are dumb. A factory robotic arm performs a single set of instructions over and over again, perfectly. If you want it to do a slightly different task, such as picking up a new shaped object, you have to stop the production line. Engineers have to spend days, or even weeks, meticulously reprogramming every movement, every angle, every degree of pressure. It's an expensive and terribly slow process. Until now. Google DeepMind, the company's cutting-edge artificial intelligence division, has unveiled a new system called RoboBallet. The name is perfectly apt. This is an AI platform designed specifically to teach generic industrial robotic arms to perform new, complex, and fluid tasks in a matter of hours, not weeks. The system uses an advanced technique called reinforcement learning. Instead of programming the movement, engineers simply give the robot a goal. The AI then takes control of the arm and attempts to perform the task thousands of times in simulation, and then in the real world. Here's a simplifying analogy. RoboBallet's reinforcement learning is like teaching a person to skateboard. You don't give them a 1,000-page physics manual explaining center of gravity and friction. You say, the goal is to stand on the board and move. They will try, fall, try again, adjust their balance, fall less. With each small improvement, their brain receives positive reinforcement. RoboBallet does the same thing, but at digital speed. The AI tries thousands of movements per minute, being rewarded for those that are smoother, faster, and more accurate. The result is not a robotic, jerky movement. It is a sequence of fluid, efficient, and almost organic movements, reminiscent of complex choreography. The future this paints is one of hyper-adaptive manufacturing. Imagine a factory that can change its entire production line overnight, with robots that learn their new jobs during the night. This goes beyond factories. Think of logistics robots in distribution centers, capable of handling millions of different items without prior programming. Think of surgical robots that can adapt to unexpected anatomies in real time. RoboBallet is not just about speed. It's about giving machines the fluidity and adaptability that, until now, belonged only to living beings. If Google's robots are learning to dance, Tesla's are getting a high-level hardware upgrade. At a recent event, Elon Musk took the stage to unveil the company's newest generation of humanoid robot, the Optimus V3. And the first thing everyone noticed was its appearance. A far cry from the black and white of previous prototypes, the V3 features a sleek new chassis made from a special metal alloy with a distinctive golden hue. But Musk was quick to point out that this isn't an aesthetic choice. It's pure engineering. This new chassis is the result of an obsessive quest for efficiency. The special alloy is significantly lighter than previous materials, while also being much more durable and resistant. For a humanoid robot, weight is everything. A lighter chassis means that the motors and actuators need less energy to move the limbs, which directly translates into a dramatically longer battery life. It also means that the robot can move faster, with more agility and less wear and tear. Durability, in turn, is what allows the robot to leave the lab and enter the real world. And that's exactly what was demonstrated. Optimus V3 wasn't just shown walking on stage. It was filmed performing complex logistics tasks at a Tesla factory. We saw the robots identifying, picking up, and moving heavy boxes, navigating busy factory aisles, and interacting with production equipment. This is the first time we have seen Optimus being tested for real work in the environment for which it was designed. The perfect analogy for this update is the evolution of armor. Early humanoid robot prototypes were like medieval knights in plate armor. They were incredibly strong, but also heavy, slow, and clumsy, consuming enormous energy with every step. Optimus V3, with its new gold alloy chassis, is like a modern elite soldier wearing Kevlar and titanium mesh. It is lightweight, flexible, and allows for a full range of motion while offering superior protection. The future of this technology is the redefinition of manual labor. Musk is not building a stage assistant, he is building a worker. A humanoid worker that can, theoretically, perform any task a human can. With a lighter and more durable chassis, the V3 is one step closer to being a viable workforce, capable of operating 24 hours a day in warehouses, factories, and eventually in our homes. From the Industrial Revolution to the Surveillance Revolution. In the field of espionage and military reconnaissance, the game has always been about remaining invisible. For years, drones have become the eyes in the sky. But they have a fundamental problem. They look like drones. A quadcopter or fixed-wing aircraft produces a characteristic sound and has an unmistakable silhouette. They are easy to detect, both visually and by radar. The solution? Don't build a drone that looks like a bird, but build a drone that flies like a bird. A military research institute, whose details are kept secret, has unveiled a new ornithopter. This is not a toy. It is an advanced spy drone that does not use propellers or jet engines. It flies by flapping its wings. The prototype demonstrated not only looks exactly like a large eagle, but more importantly, it perfectly mimics its flight patterns. It does not flap its wings constantly. It flaps its wings to gain altitude and then glides on thermal currents, just as a real bird of prey would. It tilts its tail to maneuver and adjusts the geometry of its wings to change speed. Let's use an analogy from the world of camouflage. A traditional drone, such as a Reaper or a quadcopter, is like a soldier trying to hide in the jungle wearing a gray business suit. It stands out. This new ornithopter is like a sniper in a full ghillie suit. Not only does it have the colors of the forest, it mimics the texture of leaves and branches. It becomes part of the environment. To an observer on the ground, or even to a radar system looking for linear and mechanical movements, this drone is just another bird in the sky. It is camouflage in 4 dimensions: appearance, sound, movement, and radar signature. The implications for reconnaissance are profound. We are talking about a surveillance device that can operate over sensitive areas in broad daylight without raising suspicion. It can hover for hours, observing, listening, collecting data, and be mistaken for local wildlife. This is biomimicry taken to its military extreme. Nature has spent millions of years perfecting efficient and silent flight. Now, military engineers have simply copied that lesson to create the near-perfect espionage tool. Robots are becoming smarter, lighter, and more stealthy. But they still have one fundamental weakness. They are fragile. The Optimus V3 may have a durable chassis, but its sensors, circuits, and joints are vulnerable. One cut in a cable, one impact on a sensor, and the robot is out of action, requiring expensive and complex repairs by a human technician. What if the robot could heal itself? Like a living organism. Soft robotics researchers have just unveiled something that looks like something out of the movie Terminator 2. It's a new living electronic skin for robots. This skin is not hard plastic. It is a soft, flexible material, much like human skin. And, like human skin, it is full of sensors. It can sense subtle levels of pressure, texture, and temperature changes. A robot with this skin could feel the difference between holding an egg or a metal ball. But the truly revolutionary part is what happens when it is damaged. When the skin is cut, it bleeds, a special, conductive liquid, which is stored in microchannels within the material, immediately leaks out to fill the cut. This liquid then undergoes a chemical reaction when exposed to air, solidifying within minutes. The result? The wound is closed, the skin regains its structural integrity, and, most importantly, the electrical circuits that pass through it are restored. The robot heals itself and its senses return to normal. The analogy here is almost literal. Think of a standard electronic circuit, such as your computer's motherboard. If you scratch and cut one of those copper tracks, the circuit is broken. The computer is dead until someone solder it. It's a fragile system. This electronic skin works with the human body's healing system. When you cut yourself, your circulatory system sends platelets to the site, which form a clot and seal the wound, allowing the skin to regenerate underneath. This conductive blood acts as both the clot and the solder, all at once. It's an autonomous, instant repair. The future this enables is one of truly robust robots. Robots for space exploration that can withstand micrometeorites. Search and rescue robots that can enter rubble without fear of crippling damage. Prosthetics that not only feel the world, but can also heal themselves from scrapes and cuts, just like a real limb. We are giving machines the resilience of biology. Finally, we have given robots biological brains, fluid movements, lightweight chassis, stealth flight, and skin that heals itself. What is missing? What is missing for us humans to dive headfirst into the digital world we are creating? Until now, virtual reality has been an incomplete experience. We put on headsets and have 360-degree vision. We put on headphones and have spatial sound. But when we reach out our hands, we feel nothing. The metaverse is, so far, a world of ghosts. The startup, Haptex, plans to change that forever. They have just unveiled their first full-body haptic suit designed for the consumer market. Haptex has been known for years for its industrial-grade gloves, which cost tens of thousands of dollars and are used by NASA and car manufacturers. Now, they are bringing this technology to a full suit. The system doesn't use simple vibration motors, like a video game controller. It uses much more advanced technology, hundreds of pneumatic micro-actuators distributed throughout the suit. Let's use a simplified analogy, as this is key. Think of your cell phone vibrating in your pocket. It's a unique sensation, a generic buzz. That's the extent of haptics that most people are familiar with. Now, imagine the Haptex suit. It is covered with hundreds of small computer-controlled air bubbles, each the size of a pixel. If, in the virtual world, a raindrop hits your shoulder, the suit instantly inflates a single bubble at that exact point, simulating the impact. If you touch a virtual brick wall with your hand, actuators in your fingers press against your skin, simulating the rough texture and solid resistance. The suit can simulate complex textures, precise shapes, and varied impacts. In a demonstration, users reported feeling the impact of a tennis ball, the sensation of walking through tall grass, and even the presence of a virtual wind. The future of this is, frankly, the final bridge to digital immersion. We're talking about entertainment that you don't just watch, but feel. Games where a hit is felt. Medical training where a surgeon can feel virtual tissue. And, perhaps most profoundly, social connection. The ability to feel a handshake or a hug from someone on the other side of the world. Haptex isn't selling an accessory. It's selling the sense of touch to the digital world. The future is accelerating on all fronts at once. Biology is merging with silicon. Artificial intelligence is learning to move with the grace of a dancer. Robots are gaining stronger bodies and skin that heals itself. And we humans are about to gain the ability to touch the digital world. The big question that remains after all this news is, what happens when all these technologies converge? Think of the Optimus V3 robot, now with self-healing skin, being trained by Google's RoboBallet AI and, perhaps, controlled by the hybrid biocomputer. We are witnessing, piece by piece, the assembly of something totally new, A new form of intelligence? A new way of working? Or a new way of life? Which of these advances do you think will change the world the fastest? Leave your opinion here in the comments. If you are as fascinated as I am by the speed of these changes and want to stay at the forefront of the future, join this community. Subscribe to the channel, turn on notifications so you don't miss any updates, and most importantly, keep asking questions. The future is incredible, and it's happening now. Check out these other videos appearing on the screen. We have in-depth analysis on where AI and robotics are taking us. Keep exploring. See you next time.